All right, for our first example here, we're given a relation. We can see this relation here, and we want to discover, is first of all, is this relation a function, and what is the domain and range of this relation? So to start us off here, when you look at the concept of domain and range, your domain is your input values. So let's call this relation set A, and therefore the domain of A here are my input values. My input values, as you can see, are the initial coordinates here. So 1, 2, 3, 4, 5, and 6. So writing that in set notation, the domain of A is 1, 2, 3, 4, 5, and 6. The range of A is now the output values. Those output values are 1, 1, 2, 3, 5, and 8. So you don't want to repeat them. I don't have to put 1 down twice. I can just go 1, 2, 3, 5, and 8. And that represents the range. So now I have the domain and range of this relation. Now the question becomes, is this relation a function? And for this relation to be a function, each input value can only be sent to one output value. So for instance, 1 is being sent to 1. And we'll notice here in this relation, 1 is not being sent anywhere else. The same can be said about 2, 3, 4, 5, and 6. You'll notice here for this first sequence here, 1 is sent to 1 and 2 is sent to 1. That does not mean that it is not a function. So this relation is in fact a function. And again, just because 1 is being sent to 1 and 2 is being sent to 1, that doesn't negate the fact that this is a function. Now, had 1 been sent to 1, and let's say instead of 2, 1, I had the input value 1, 3, then these two combined would mean that we have a relation but not a function. All right, let's take a look at some more examples. So for this next sequence here, you'll see that right away this relation 2 is being sent to 2 and 2 is also being sent to 3. So for the input value of 2, we have two different output values, 2 and 3. So right away this is not a function. So we know we do not have a function here. You can still talk about the domain and range. We'll call this set A. The domain of this set is still the input values. So in this case here, it's going to be 1, 2, and 5. And the range of this relation are the output values. So 5, 2, 1, and 3. So we'll write that in ascending order. So 1, 2, 3, and 5. And now we have our domain, which is our input values, 1, 2, and 5. And the range, which is the output values, 1, 2, 3, and 5. All right, let's take a look at another example. So in this example here, we want to find the domain and range, and is this relation a function? Now, if you express this relation, start off assuming it's just a relation, express it in set notation, what would it look like? Well, you can't express every single point because this has an infinite number of points, but what it's essentially doing is no matter what y value you choose, the x value is always negative 3. So negative 3 and 1 is in this relation. Negative 3 and 2 is in this relation. Negative 3 and, negative root 2 is in this relation. And, we can continue on. You've got negative 3 and a half, etc. I think you get the point. Every x-coordinate is negative 3, and then the y-coordinates can be any real number here. All right. So you can't really express this in like set notation, identifying each of the individual points, as this is infinite in size. So right away we see this is not a function, right? You can see it's not a function. You would have remembered this graph here. This is just a linear relation, but it's a vertical line looking something like this at x equals minus 3. So you can see visually that for each fixed x value, there's an infinite number of points such that you could say this fails the vertical line test, was another term that was used, right? For each x, there's infinite number of output values, so we have not a function. So we can still talk about the domain and range. The domain of this set here is all input values. Well, the only input value is negative 3, and we see that from the set we have here, right? Every input value can only be minus 3 because no matter what, x is equal to minus 3. The output values, as you can see here, are going to be all real numbers, right? The output can be anything, and we see that visually. You can see the range of this is all real numbers. All right, let's take a look at another example. So in this example here, we have a quadratic. We can tell it's a quadratic, it's degree 2. This is already in vertex form, which comes in handy. I can quickly do a sketch of this. This has a vertex of -3, -4. So, somewhere right about here, there's my vertex. This opens upwards. So a quick sketch is going to look something like this. Now, first of all, now we want to know, is this a function? It is a relation, obviously, but is it a function? Visually, we can see that this passes the vertical line test. For every x, there is a unique y, so this is, in fact, a function. If we want to find the domain of this function, we can denote that as d subscript y. The domain is all input values. Well, every polynomial has a domain of all real numbers. There's no situation where you're dividing by 0, taking the root of a negative number. So the domain of this is going to be all real numbers. The range of this is your output values. And now you can see the range of this gets as low as what? Now, when you talk about range, you're talking about your y-coordinates. So my y-coordinate is, I'm not concerned with the -3, I'm concerned with the -4. So this range is going to be all real numbers such that y is greater than or equal to -4. In interval notation, that's going to be square bracket -4 to infinity. And then we have our domain and range of this function. All right, let's take a look at another example. In the next example here, we have ourselves a quadratic again. I can see it's degree 2. I know it's a quadratic. So right away, we can see that this is in fact a function. You can see here for every x, there's a unique y. And the reason I know that is because it's degree 2, it's either going to open up or down. And in that event, if it's either a quadratic opening up or a quadratic opening down, both of these pass the vertical line test, in which case we have ourselves a function. So now if I want to talk about the domain and range, the domain is easy. The domain of this function is going to be all real numbers, right? There's no situation where I'll be dividing by 0, taking the root of a negative number, so I don't have to worry about any of that. We've got the domain set. It's going to be all real numbers. The range, on the other hand, is a little bit more difficult because we do not have the vertex. So we have to find the vertex. Quick way to find the vertex here is you can complete the square. You can try to factor it, find the roots, and average them out. Or you can just let x equal -b over 2a. And if you recall, if you're in standard form, you have to be in standard form. This is my a, my b, and my c. You sub that all in to your equation here. This becomes -3 over 2 times -2 is equal to 3 over 4. So my axis of symmetry of this quadratic is 3 over 4. I need the y-coordinate. If you recall in the previous example, I needed that -4, the y-coordinate. I'm going to need the y-coordinate here to denote the range. So I have to sub this back into my original function. Okay, now, so I'm going to go ahead and sub that 3 over 4. I'm going to put that into my function here, y, and get my corresponding y value. Doing so, we get the following. So going ahead and calculating this here, I get the y-coordinate is -31 over 8. So this is quadratic with a vertex at this value here, opens downwards. So the range of this value here, range of y, is going to go from -infinity to -31 over 8 with the square brackets here. So this is in fact a function. Domain is all real numbers, and the range goes from -infinity to -31 over 8. Let's take a look at another example. In the following example here, this is the equation of a circle. So you'll notice here, this is a circle centered at the origin that has a radius of 4. So this point here would be the point 40. This point here would be the point 0.04. And we can see here that this is obviously not a function. You're getting for a fixed input value. Let's even say something like 0. You've got 0 goes to 4, 0 goes to -4. So this is not a function. But we can still talk about the domain and range of this. The domain of this, let's call this set R. The domain of this relation here is going to go from what? Your domain is your x values. So my domain has a lower bound of -4 and an upper bound of 4. And the range of this relation has, again, a lower bound of -4 and an upper bound of 4. So this example here, this is a relation, not a function, with the following domain and range. Let's look at another example. In the following example here, this is the square root function. It's just shifted a bit. So to see what the transformation of this is, we're going to have to go ahead and factor a 2 out of this binomial, giving us x plus a half. And we can see here, if I were to do a rough sketch of this Square root function, it's essentially your square root function. And what it is doing is it's being shifted half a unit to the left. And then you have a bit of a compression in the x value by a factor of 2, which visually, in terms of calculating the domain and range, that's not going to affect it at all. So let's just do a quick sketch of this. This is just a transformation of our root x function. So it's still a function. In terms of the domain and range here, you can see that the domain of this function is going to be all values of x such that x is greater than or equal to minus a half. And the range of this function is going to be at 0 all the way up to infinity. And we have here the domain and range. All right, let's take a look at this expression here. Now this is actually going to be, if you were to square both sides, you would end up with the following expression. So what this is this is really a circle centered at the origin that has a radius of 3. Now, because I squared both sides, I introduced the possibility of extraneous roots, and one of those was the top and bottom half of this circle. So when you square both sides, I introduced the option of like a plus or minus on this, which gave us the top and bottom of the circle. So really, the original form of this was the positive square root. So that represents only the top half of the circle. So this bottom half of the circle here is not actually present. So if you take a look here, this is really the top half of a circle, looking something like this. I think you get the point. And you can see here that this does pass the vertical line test. This is, in fact, a function. You can see the domain of this function is going to be the x values, so -3 to 3. And you can see the range of this function is going to go from 0 to 3. So we have that this is, in fact, a function, and it has its domain and range. Let's take a look at the next example. Taking a look here at the next function, this is the sine of theta. You'll see here that for every x, there's unique y. It passes a vertical line test. This is, in fact, a function. If you want to talk about the domain of this function here, that's going to be all real numbers. You can see here that any value of sine is defined. And then taking a look at the range of this function, your sine function hits a max value of 1 and a min value of -1. So the range of this function is going to go from -1 to 1. All right, that concludes today's lesson on examples of relations, functions, domain, and ranges. Thank you.